we're progressing. AAM is actually moving at the moment from a geospatial company that collected a lot of data and would then distribute the data. Our particular platforms and where we work at the moment is not, I suppose, the common ground for all the global providers. We work everywhere from French Polynesia right across the Indonesian parts, obviously in Australia, Southeast Asia, through the subcontinent and into Africa. We collect a lot of data. We have a small air force of planes, we have multiple sensors, we have a very big ground force of surveyors, and we provide a lot of what's been described before as the heavy lifting to provide high resolution data and high resolution information that goes to the rest of the world. We're 55 years in operation. Every day we'd like to consider that we actually reinvent ourselves and don't focus too much on the 55 years. We see ourselves as now a producer and a provider, but also as a platform. And I guess it is that term, the platform, is the answer to some degree about what's been asked today. So we're asking, where's the money? And even in the description of what we're doing at the moment, we're saying platform. So I thought I'd take a little bit of time from today to actually just describe what we see as platform, and a little bit of talk about the platform itself, and we'll talk about the cloud, because there seems to be the concept that everyone says, well, the cloud's a good thing to be. It's a good place for us to be working, a good place for us to actually have our information, and to devise that cloud to actually work for us as a platform. But I guess there's lots of things that come to mind in our organisation that we sit around and say, so which parts of these can actually be driven well? And you can see some of the, on a day-to-day basis, some of the words, the things that float around our organisation and amongst our customers at the moment that matter. And they're all coming together and they all overlap each other and both aggregate with each other and pull each other apart. So we're focusing on the idea about how can we work in places where some parts there is no cloud, or there is no access, or in fact even the ingestion of data into the cloud becomes a bigger issue than whether I can actually access the cloud at the endpoint. So in those sort of environments, and our evolution of it as a business is we're moving from a very traditional business where we would collect the data and we would process data and we would then distribute it in some way. Originally paper maps and so on, and then onto digital forms and so on. And like everybody else, we are evolving ourselves into a platform-generated business where everything is about the dissemination and the use of that data in multiple forms. So we'll talk about reuse and the idea that data is actually moved only once in its lifespan. And that's probably the biggest unique thing that we could post up about where's the money. If data only goes onto a cloud location, if information lives on that cloud location, and is manipulated in a single location, we no longer have to worry so much about the retranslation of that data, the reinterpretation of that data, the fidelity of that data, or the precision of that data. It should be self-describing. But what the platform provides us to do is to be able to integrate multiple sources of data in multiple ways across multiple different environments. This is a quick example of some work that we did in Hong Kong, where we were combining a very rich LiDAR data set with 3D generated models, which were also done by aerial capture, with the whole integration idea of how planning could be done in Hong Kong to go move forward. In these type of platforms, however, we produce a cloud. We load the data up in the cloud, we allow the data to actually work in that cloud environment. But the challenge is that in most of those things, people have been constrained by what they've had on their desktop environments or their in-house environments or within their particular provided environments in which they're working. And we've all felt that the computing was the thing that probably let us down as much as anything. We can think of the ideas that we need to perform, we can think of the analysis we would like to do. The problem is, how do I actually get enough power to make that happen? How do I get enough storage to make that happen? And I guess one of the things that we've been working towards is to use the cloud both for ourselves first, as a business, to actually work in the cloud ourselves, to actually do our processing as a cloud-based application, and then to leave that data in the cloud and to let it self-propagate and to let itself be managed. I don't think when we talk about the cloud, though, we should assume that everybody accepts that this is a good thing to happen. There is an awful lot of the world at the moment, a lot of governments in the world will still see the cloud as a very looming and threatening thing. It does impinge on things like security and privacy, surety of the data, and even if you're paranoid, the whole conspiracy theory about how data is filtered and what you can see and what you can't see. All those things are inherent in the very nature of actually having cloud-based applications and cloud-based information systems. By the way, that particular image is off the east coast of Australia. So if you've ever been to summertime in Sydney when we get what we call southerly busters, that's sort of what happens when the weather comes up the coast. And it brings with it that change, and I guess it is that focus of change that we're all hoping to get to. But for a lot of the people we deal with and a lot of our customers, the cloud is still something to be contemplated, not necessarily something to be acted on. Right? So it's viewed as something there, but how do you actually make it work? So let's have a talk a little bit more about just what is the cloud and how is it progressing. When we look at the growth of what's happening in the internet as we stand at the moment, or at least in cloud-based, and this is about information as a service. And information as a service at the moment, averaging about $38 billion being spent on actually providing that as a process for us to actually work with. And if we look there on that particular chart, you'll see by 2020 we're saying that there'll be $126 billion spending on the information systems around this. What's fascinating though, if you go back and have a look at some of the analysts, and I went over a couple of these type of things, the best one I could find probably was from Group 451 Research out of Boston, which is then analysing how much the market would be worth in that same time for the same services. And the fascinating thing is, the market will be worth only about 1/3 of what's been spent in actually developing the infrastructure, which is the cloud. So clearly, and in taking on Dr. Mohan Reddy's comments, there is a huge investment going forward that this will progress faster than the market can actually consume it. And I guess the challenge I'd put to everybody here in working with Geospatial is we have been very, very slow to actually consume what's available in the cloud. We talk about it a lot, but not many organisations actually get their data up there. Not many organisations are available to actually work with even the concept of open data. We talk about open data, but it's still on a slice up, give out, take it away like a pizza. It's not available. It's not something that's uniquely available. It's not like a radio that you can turn on and now I can go get my data. I can work with it. That isn't what's happening for a lot of the data that's still in the world at the moment. So if we've got a market circumstance which is consuming or at least spending much, much less than what the cloud providers are actually spending and making it available, how do you make the economics of this? And one of the things that's interesting, and this is a quote from the Tata organisation, we're doing, this was a 2014 presentation, and then in 2015 they updated it, and at that stage they estimated that 70% of the financial services of the world were conducted in the cloud. The challenge I'd put to this room, do we honestly believe that 70% of the geospatial transactions of the world would be conducted in the cloud? And I think we'd be hard-pressed to actually believe that. So the challenge to this room is we have the facilities, we have the platform, we have the way to actually reach to money, but we're slow to react to it. So what does the cloud bring us? Obviously the cloud brings us agility. AWS, the largest cloud provider in the world, estimates that it's the #1 answer that's given to it by its clients as to why people want to be on the cloud. How agile can you be? And part of that agility then is being able to make sure that you can react to these things and make money from that agility. So, as we're looking at the moment, we've got several different things that we need to do. We need to replace our current things and look for where we can move from large CapEx environments to much more containable OpEx environments. We make sure that we can expand and grow at a reasonable rate, and we make sure that the services that we're providing can be charged on an as-needs basis. I'll probably cheat a little bit, and I'll drop back to a little bit of slide that I took from AWS as an example of what actually is presented from the cloud itself and what we can actually hope to achieve. And one of the concerns is always about the security. It's an interesting thing that most of us will believe that our bank accounts can be secure on a cloud-based scenario, but we don't believe that a digital photo of our house can be. So we have an interesting conundrum actually facing this at the moment. The governments of the world, and for large parts in the parts where we play, have yet to embrace a lot of the concepts around open data, and in some parts yet to embrace some of the concepts around how we will actually have secure environments on a cloud-based institutionalised environment. My argument is that in a lot of these cases, there's already a series of certifications, a series of processes for which these cloud-based, and in particular the large commercial cloud-based organisations, have exposed themselves for the levels of accreditation that they've got for security in place. What you need to do is impose your levels of hardening and your levels of security on top of the already available security systems there. That means no less a part for your IT, no less a part for your GIS people, no less a part about doing things like identity and access security systems. And in getting to that particular point, how quickly can we actually make this work for us? And how quickly can it actually grow if we were actually to take all our spatial data and make it available in commercial clouds? Amazon, and I use Amazon, and I don't mean to be an advocate of Amazon, but they are the largest commercial cloud propagator in the world at the moment. They claim that on every day they add more server space than was originally available to Amazon when it first hit a $7 billion company. Now, to give you an idea of that, that was 2005. So if you think about this, at 365 days a year, they expand at that rate. Go backwards, Amazon now sits at about $107 billion a year revenue as a total company, and AWS is the fastest growing component of Amazon. Mind you, if you look at their spending that we saw before as well, you can see that they spend a lot of that going back into the cloud-based facilities. So let's have a look at some of the things that become available to us. And there's lots of little writing, so that probably doesn't help, certainly doesn't help my eyesight, but there are a lot of products available on the cloud, and they productise what's available to you, how to actually use cloud-based technologies to make some sense of it. One of the ones that I'll pick on an example here, is the idea of having workspaces. You can literally create your own individual workstations, your organisation workspaces in the cloud. And one of the newer technologies is to move from even CPU usage in the cloud to GPU usage in the cloud. Now that means a big deal for us as geospatial type people. We have a lot of imagery, we have a lot of high intensity data sets that need a lot of GPU type capabilities to progress, because that's where our software development is focused on over the last 15 years. You can now actually take a workspace on a commercial cloud that mimics your GPU usage, which means that you can take an application or anything you've got in-house at the moment, move it to a cloud-based activity and make it hugely scalable. That's pretty exciting. It's also exciting that I can capture data, for example, in Papua New Guinea, load that data onto the cloud, have people work on that data who are sitting in Malaysia, and have my client who's consuming that data sitting in West Africa. That data doesn't have to move in any location, and they can do that with exactly the same view via the workspaces and the VDI type capabilities that are available within cloud-based at the moment. I know I get a little bit geeky when I start talking VDIs and so on, but you'll get the idea as we move. So how distributed is the cloud? As you can see, most of the commercial large cloud organisations, this goes across the Amazons and the Googles and the Azures and so on, have multiple nodes around the world, high levels of redundancy that are regionalised. Right? The idea behind this structure is that no set data collapse anywhere in the world will cause a catastrophe that can't be recovered. It also limits the amount of lag in actual application usage. One of the things that we need to do, we need to fix Africa though. Right? On a global scale, Africa lags at the moment between having node-based locations for any of the major cloud providers. And that's clearly something, while it doesn't make cloud unusable in Africa, it does mean that it's harder for it to actually work there. So if everyone wants to join me in petitioning various African governments to petition any of these cloud providers to put things there, then we would certainly benefit from it as a global community. We need to build our clouds, and in building our clouds, we will add new employment systems, new development environments, new production environments. We can add thousands of servers on demand. And the services can be things that, for example, to buy things either as predetermined size models or as on-spot or on-demand models to actually undertake your work. So we move off, talk about our application, which is GeoCirrus. So GeoCirrus, for us, brings this all together. We are a cloud-based system now. We like to acquire our data, we process our data, and we store our data, and we create applications and allow you to create applications around that data, all in the cloud. Just for those of you who may not come from the geographic background, of course, Cirrus being the type of cloud. Okay, so we move on. Again, further mapping in the 3D space, and it is the 3D space that I'll pay some attention to for the conclusion of this. GeoCirrus, it's a cloud platform, enables you to take advantage of the cloud's flexibility, reliability, high availability. I joked around before when I was saying, well, that's a lot of ability. But it's true. They are the things that distinguish what we can actually do in cloud-based computing or cloud-based platform. So when we look at real examples of those, and I'll thank SLA, who have got some members here today. This is Singapore Land Authority's data for virtual Singapore at the moment, which is a very high resolution model set of Singapore being created. And we're working with Singapore Land Authority as to how we will actually make that available to the rest of the Singaporean government and the other authorities. Other data sets, and this can move now to the simplicity of a single application, which might be as simple as actually imposing building or planning envelopes. To be able to plan things as what we might see as trivial on one hand, but important on the other hand, such as New Year's Eve celebrations in Sydney, and what might a plume look like on that particular application, and integrate data from multiple sources. Or we can deal with the richness of very high resolution data for planning mechanisms in different parts of the world and transport mechanisms. Again, integrating multiple data sets from planning mechanisms in both real and non-real time on top of 3D visualised environments. More of the 3D visualised environments. I guess when we get down to talking about it though, the real thing is about this 3D, and we've all mentioned, and we can see 3D, and we visualise 3D. So how do we interact with 3D? What is it that actually means that you and I could do the type of analysis, the type of understanding of the third dimension that we could do, or we grew up with, in 2D GIS? And I'll come back to the term GIS, because one of the things we face when we get to the 3D space here is perhaps the changing of the things that we all held sacred about GIS. Planar enforcement, topology, symbolisation, generalisations and so on, change their meaning when we move into a third dimension. And if we're looking at the idea of being able to integrate discrete models in the third dimension with things like reality meshes, for example, and imagery from all sorts of different sources and real-time data, then we have to rethink a little bit about how we're going to work with that data. And our applications have to move a little bit from where they've been. So in moving to these types of things, we have to get to that integration point between the CAD and the BIM world and between GIS. And on the outset, that of course sounds very simple, and everyone assumes that that will be easy to do. But when we get to working with BIM and trying to integrate that into geospatial components, there is a little more to play in that game than we've yet to work with. So some of those things are coming to pass. And I think things like the OGC and their standards, because that's making life extremely, or at least a lot easier for us than it has been in the past. But if you took your average architectural model, and most of us can have experience with an architectural model at some stage in their life, and understand the difference between that and what you might know as a precise geographic model, becomes a difficult thing to actually try and bring together in one interface, in one solution, in one type of application. But it is the power that we can actually put behind things like the platform behind this to actually do the translations, to do the integration, to actually work with a single set of data for the end client productions. And of course, this might go down to as far as doing the sort of things we've been talking about even earlier today, such as indoor mapping, for example, BIM generations and so on, and how they might be visualised in the same frame, in the same type of conversation around traditional GIS information. Some of our other types of information sources for which we would actually serve from our GeoSeries platform at the moment, and these are around things like power line applications, for example. So the one here, it's on my right, is where we're not so interested in the power line. What we're interested in is the vegetation intrusion into the power line space. In Australia and a lot of other parts of the world, such as South Africa, for example, and in parts of California and so on, one of the really great problems about power lines and overhead power lines is the effect of bushfires or wildfire. So we do a lot of monitoring of these types of things. In this particular application, the client has a very sophisticated online application which they built for themselves, which pushes a coverage envelope down each of the catenaries of the wires, not dissimilar to what we heard before when Ron was talking about his train intersection with the tunnel. And the idea is to pick up where vegetation encroaches on that path. We go a little deeper than that though. He processes that same data to work out what the vegetation density is, and then to work out what type of field team is actually dispatched to deal with that. So whether that's deals with it as a herbicide or deals with it as a cutting process, and even to understand what the regrowth rates will be over a period of time. So some of those applications built by the client in that space as a platform means that they can actually undertake that without having to really go out and buy themselves a GIS in the traditional sense of that. Further applications, and you would have seen these types of things before, which are around the idea within the 3D space of things like solar potential, for example, and sun angle penetrations, which all add to the amenity of what we now call the city and the smart city environments, shadow analysis and all the other effects that we might expect to see in urban space. Further examples of the same sort of things, and the last ones is where we get down to the more sophisticated buildings, and while I admire the architecture here in Rotterdam, which is quite exceptional, there are some architectural types in the world at the moment which are failing to actually adhere to any form of what you and I might call form. And in some of these cases it does require a high level of modelling to actually get these into your applications. And you can see on some of these things in cloud-based applications, we can actually do this now online against a foreign data set, which is quite exciting. So, we talk about what needs to happen then, and what you will expect for your value proposition, not just my value proposition. And I would say that you will need to embrace the subscriber payment. So the idea is you will pay as you use. So to buy an annual perpetual license of a particular block of monolithic software will probably fade away in favour of being able to take much more modular components. A word that I've used in the past has been atomisation of actual software blocks. We can see this in some of the other applications that we now use, but probably not as strong as you might expect. If you look at the greatest proponent about cloud-based in office environments being something like Microsoft's Office 365 or Google Apps, then probably not as broken as they need to be. They need to be atomised to a point where people can actually take up very small chunks. I don't need to take on a whole application of PowerPoint to do most of what I do, which is change lettering. So in the same way, the urge for me about where the value is in where we are with geospatial applications is to allow people to actually build applications of very small chunks and license around that. We will, of course, get to the point where we will be combining traditional GIS layers with other forms of data. And there are some still complexities about that to be sorted out. We're working our way through it, and I think most of that will be handled inside the next, within reasonable times, say a year to 2 years from here. For us, it's in the Geo Cloud, and I'll call it Geo Cloud because we really haven't used the cloud just yet. So if we're going to do it, one thing I notice about the geospatial world, we have to add a prefix to it. We've got to do something with it. We've got to call it Geo Cloud and embrace it, and actually make something happen from it. For you, embrace the capability, flexibility of Geo Cloud platforms, and allow the cloud to move you from what's been a relatively static data environment to a fluid data environment, where the data can move, the people can move, and everything will happen around one solid platform. Thanks, Enya.